All right, welcome to a new episode of Protocol Explorer. So today I have Konrad with me from Rhinestone. Konrad, can you tell us a little bit about what you do, what Rhinestone is, and what we're going to be talking about today?
Great to be here, and then thank you for having me on. I'm Konrad. I'm one of the co-founders of Rhinestone. Kind of roughly what Rhinestone is we build infrastructure for modular smart accounts. Kind of maybe I can start with a bit of background on myself. So I've been working on Rhinestone for over the last year. We actually got started at ETH Denver last year. So there we built the first kind of like modular and native 437 kind of smart account. It was based on diamond proxies, and kind of like we evolved from there and into kind of like building more infrastructure. And then before that, I was contributing to different open source projects in the Ethereum ecosystem. But kind of Rhinestone specifically, it comes from the idea of we now have like account abstraction, and we have these smart accounts. But the problem is that one way to build those smart accounts is kind of like in this monolithic way. So you essentially kind of like as a developer that works on these accounts, you say these are the features that are in my account. So it might be certain validation logic, it might be certain like security assumptions, and kind of like just certain behavior that's kind of baked into the smart account. But as a user, like I essentially have no say over kind of what those features are. And it can be very hard for me to switch from one account to another account in order to get new features. So kind of the idea there is instead of building these like monolithic accounts, you can build them in a modular fashion. And that means that kind of a user can kind of like plug in these different kind of feature components, kind of a bit similar to how you would install apps on your phone, or kind of like extensions in your browser or in like your code editor or something like that. And then on the other hand, kind of developers that don't necessarily need to be the account developers could actually build these like feature components, which is what we call modules. So yeah, that's kind of the high level idea of modular smart accounts. And kind of actually so far, pretty much all the major accounts are modular. So Safe has been for a very long time. Kind of Biconomy and Zero Dev, which was like the prominence over the last year, have been like very used, are also built in the modular way. So kind of it seems like that's where the trend is going for the general like smart account ecosystem.
Cool. So I know there's a couple different, I guess, standards competing in like the modular space. So Alchemy kind of has been pushing stuff on like I believe 6900. Is that correct?
Mhm.
Um, and then there's the standard that y'all have been working on with like Zero Dev and Biconomy. Can you kind of like go through like what are kind of like the differences between the two and like why you guys kind of like went with this approach?
Yeah, for sure. So yeah, like you said, there's ERC 6900, which kind of got started over a year ago now. And it was kind of pretty early to the whole like modular smart account kind of movement. And a lot of people kind of initially were quite excited about the standard because um, there is kind of obviously this problem of kind of different people build these different accounts in a modular fashion, but kind of like in a different modular fashion. And then the problem there is like as a developer, I then need to build and maintain all of these different kind of like instances of the same module. So that's obviously a huge pain point for developers. And kind of for users, it also means like it's much harder for me to get like visibility over which features I get with which accounts. So kind of like the need for standardization is definitely there. And kind of we like a lot of the other players, like you mentioned, kind of Zero Dev, Economy, and so on. We're kind of like waiting around, kind of seeing what was going to happen with 6900, kind of like trying to contribute a bit, and kind of like yeah, just kind of like I said, like kind of waiting to see kind of how it evolves. But then kind of over the last half, or kind of like I guess in fall of last year, it kind of became like more obvious to us that like 1600 has a very kind of like specific and opinionated interpretation of how these accounts look. And essentially, it makes like a bunch of like design decisions which make sense for a specific account instance, but might not necessarily make sense for all the account instances, because we still want kind of like innovation and kind of like people to try out new things. And so we got together with people like Zero Dev, Economy, OKX. Since then, there's been kind of like more supporters of the standard that are kind of have built accounts or built modules. Kind of got together and said, like, how can we still kind of aim to achieve this goal of like standardization, so that developers can build modules, kind of build them once and use them across all accounts. But how can we do this in a way where the account builders can still innovate and the account builders can still kind of make important decisions for those accounts, whether that be on security, whether that be on kind of like how the account actually behaves. So the idea with, and this is where ERC 7579 kind of like was born basically. And the idea there is kind of we took all of the learnings from the existing accounts and kind of like try to make the standard as minimal as possible so that, yeah, like the account kind of builders could make all of the important decisions and while we still get this interoperability.
Got it. So would you say that as opposed to 6900, this might be more friendly on like the DevX side of things?
Yeah, I think there's multiple layers, as in like there's multiple like developers, I guess. So on the one hand, for account developers, it might be kind of like harder in the sense of like you have to make more decisions yourself.
Mm-hmm.
But kind of like the flip side of that is like you get to make more decisions yourself. Like you actually have much more control over what the account looks like. And then kind of, I do actually think that 7579 is kind of more friendly on the module developer side because it is just much less complex on the module developer side. So one thing that, for example, 7579 does is it breaks modules into different types. For example, like validators, which get called during validation and perform validation logic, then hooks, which is kind of what we'll look into a bit later, which basically get called before and after execution. So they kind of like hook the execution and then perform certain checks. Whereas like on 6900, at least right now, like these are all kind of in one. So developer has to think about all kind of like the entirety of like flows that the account does when building a module rather than kind of like building or thinking about that specific use case. So I think that's one area where 757, like building a 7579 module is actually kind of like requires much less knowledge on the module developer side.
Gotcha. Makes sense. Cool. So given, I guess, my next question, I guess, would be around current events in AA and like how that affects everything. So recently been a lot of chatter around like 3074 coming into play and being merged in, as well as now, as of I guess yesterday, a brand new standard to compete against 3074. How does this kind of like affect you guys in like building out these like different modules for smart accounts? Do you see this being a help towards like moving towards smart accounts, and how does that work out?
Yeah, for sure. So kind of, I guess I didn't explicitly say this before, but kind of what was implicit is like our thesis for the smart account ecosystem is that these accounts, and it doesn't matter how the accounts look like, in terms of like interfaces and stuff, but that most or all accounts will be built in like this modular way. And that means that kind of like there'll always be a need for modules and kind of like module developers and the infrastructure that supports this. Obviously, kind of one question there is kind of how do these accounts look like and kind of how fragmented will this be? Like, will different chains like CK Sync like have their own account abstraction solutions? Will there be like 437 and something like 3074, which are potentially like there is some overlap, but like not a whole bunch of overlap? So I think those are some of the questions that we've been thinking about. So yeah, we started prototyping kind of on the 3074 side, especially kind of combining it with 7579 and 437, and kind of seeing like if we build these invokers, which are like like the kind of like 3074 equivalent of like a smart account, like how different would they be kind of to smart accounts as they exist today? And like crucially, like could you reuse the same modules, or do we have to kind of like rebuild most of the stuff? And we started prototyping and actually figured out that a lot of the modules are actually fine. So we could reuse a lot of the modules, which would be great. Some like kind of executors that have like specific execution logic would need to be rebuilt. But yeah, that was one of the things we found. And we got involved in kind of like the discussions around the standards and especially I think like one discussion that was maybe had more internally in like the AA mafia and less so like kind of I guess in like public forum is like to what extent would it make sense to include something like 5003, which basically allows an EOA to permanently upgrade to a smart account, and to what extent like does that actually make the path from EOA to smart account kind of like more visible or like more apparent, if that makes sense, rather than kind of just having something that sort of say like gives EOA superpowers, but there's no clear way to then kind of like go further to like a fully like fleshed out like smart account. But so that was some of the thinking. That was some of the thinking we've been doing, and then obviously, like you said, like yesterday, there was a breakout room, and like an hour and a half or something before that, Vitalik proposed a different EIP, which I guess like kind of roughly is similar to 3074 and what it tries to achieve, but is different in terms of kind of how it achieves, and that has some implications for kind of like reusing the existing like infrastructure and tech stack. So kind of like on a very high level, instead of like introducing like opcodes, it uses a new transaction type. And kind of like what that implies is that it's actually a lot easier to reuse existing smart accounts in almost the same way as they exist today. And I guess like by extension modules, if that was the case. But yeah, obviously it's still quite early. I think so far, like it seems like most people are getting behind it, from both sides in terms of like people that were behind 3074 and that weren't. But yeah, I think it'll be interesting to see kind of how it evolves. And yeah, I guess like overall my take so far is that it would probably be a better way kind of forward than 3074. But yeah.
Nice. Awesome. Thank you for going through all that. Cool. Maybe we can then shift gears to what we're going to be doing today. Can you tell us a little bit about you mentioned hooks a little bit a while ago, and it's what we would be going to today. Can you just give us an overview of what we're going to be building, what we'll be exploring on this side?
For sure. Yeah, so like I mentioned, kind of there's different module types, which essentially have different functions. So and the main module type we look at today is hooks. Like I said, like basically you have a smart account and there's some execution, or kind of like it can be a batch of executions, and from that smart account. And the idea of hooks is that before and after these executions, this hook will be called, and it can check certain things. So it can either be kind of security measures. Like very simple examples would be like you can have a whitelist of contracts that the account can interact with, or kind of like similar, or you could kind of depend on some third party for this. And another example, which is kind of what we'll build today, is you could have like spending limits. So basically, the idea there is you have an account, you want to spend some ERC20 tokens, but you want to set some limits over a time period. Like for example, you want to say like per week only spend like 200 USDC. And then kind of every time you create an execution, this hook will be called and it'll check like, are you trying to spend USDC? If yes, like have you already spent like your allowance over this time period? If you have, then kind of like reject this transaction. And if not, then kind of like increase kind of what you spent so far and kind of like continue. That's like the rough idea. But yeah, do you have any questions on that, or what do you think?
I think that makes sense so far. Pretty easy to follow example. I like the whole concept of like spending limits. Um, I think just really being able to add additional functionality to an account itself is very, very cool. I think spending limits is definitely something that is easy to follow for most folks. So yeah, I'm excited to dive in.
Nice. Great. Yeah. Yeah, I think so as well. I think kind of when people think about features they would like to add to their existing wallets, or kind of would like to have in a smart contract wallet, I think a lot of times people start to talk about spending limits. I think one thing that's less talked about is like you could definitely build an account that just has spending limits natively. I think kind of the tricky thing there is like, and I guess we'll notice this a bit later, but like there's a lot of different ways in which you could build spending limits, and kind of like a lot of design decisions to make, in terms of like what are you optimizing for, kind of like what are the features that you actually want, and so on. And one of the really cool like upsides of using modules is actually different people can build different kind of like implementations which make different design decisions. And then you might choose one of them, I might choose another, or then later I might swap out to kind of like the one you're using, and so on. So I think that's quite cool as well.
For modules, like I guess since you have like different folks kind of building different modules, maybe different implementations of the same ones, like you mentioned. Um, from like the end user perspective, would it be like, let's say I have some type of smart wallet that has the ability to use these modules. Would I choose what modules I want my smart wallet to actually have, or would that be up to like the dev who built out the wallet interface to actually figure out how to integrate that?
Yeah, I think that's kind of still an open question in terms of like obviously technically both are feasible. In
Mhm.
terms of what will actually how we'll actually see it play out, I think is somewhat still an open question. So I think like I could see both things happen, even kind of like in parallel. So I guess like one idea there is like similar to how you have embedded kind of wallets and apps today, in dApps today, you might come to a dApp and that app might say like, here, like I'll create a smart account for you, or you already have one, kind of like, please import it or whatever. And then it might say kind of like, to get the full experience of this app, you need like this module and that module. And those will kind
Mhm.
of like power like the experience here. But then you might also kind of, as a user, you might also have a wallet, or maybe it's just kind of like a simplified wallet. Maybe it's just a control center where you can go and say, like, these are some modules that I always want. Like, for example, those could be like more security related, so that like no matter which app you're in, like that module is actually there, and that could be like a spending limit. So that's kind of like independent of the app, but you always kind of have that there. So I could definitely see both of these like play out like in parallel or by themselves. So yeah, I think like we're still early enough to be able to see kind of how it plays out.
Yeah, I almost like feel like this opens up wallets to being almost like their own OS in sort of in one way or another, because like you're putting in kind of like these different capabilities, different modules. You kind of view them, at least the way that I'm kind of like consolidating in my head is like I kind of view these as being like apps themselves, and this is just like the OS, and I'm installing these different things. Do you feel like that's a good way to like think through this whole thing? Or
Yeah, I think so. Like once again, I think there's kind of like two paths forward. I think one is like similar to wallets today, like kind of wallets still become, or maybe even more so, become the central touch point for users. I guess like one good example is like the Safe kind of wallet,
Mhm.
where like the Safe web interface, where you also have apps, and those are actually just apps that are embedded in an iframe, but kind of you still stay in that wallet, and kind of like in that like browser. And I think like Rainbow is kind of working on this, and then different wallets as well have kind of like the in-wallet browser. And kind of in that world, like wallets become those super apps. And yeah, in that world, you might have kind of like these apps, like some of them might be normal apps, and some of them might be like powered by modules. I think the other future is kind of like very much the opposite of that, and similar to kind of like the embedded wallets, is kind of you go to a app and like kind of there's this invisible wallet that you kind of like carry with you, and like it's always the same wallet, like obviously unless you have multiple for some reason or another, but like it's kind of like the same wallet you carry across the apps.
Mhm.
And actually the functionality of the wallet changes when you install these different modules. But it's much more kind of like you go from app to app rather than kind of like you have this super app, which is like a wallet.
Right. Cool. Makes sense so far. Awesome. So yeah, maybe we can dive into the ModuleKit SDK. I'll go ahead and present my screen.
Great.
So I've got the docs pulled up here. For folks tuning in, you can view this page at docs.rhinestone.wtf. So that's all there. Everything that you see on the screen is accessible there. Cool. So yeah,
Fantastic.
how do we get
Yeah,
started here?
yeah. So I guess like I haven't mentioned this before, but kind of the tool we'll be using today is called the ModuleKit. I guess like maybe like obvious because we're using it to build modules. But yeah, if you can head to the ModuleKit either by pressing open down there or on the yep. And then if you head to getting started, so the second item there, I think what would be easiest to get started is if we use our template. So if you press the link to the module template, just kind of under using, yep, that one. And then this is a GitHub template, so you can just top right kind of use this template
Cool.
to create a new repo. Great.
Cool.
Nice. Great. So yeah, so that's the kind of like the module template to make it easy to get started. And you can see it's just kind of like a Foundry repo. There's a README, there's kind of like a source, test, and script folders. And if you go to the source folder, there'll be a couple of templates there already. So that'll be executor, hook, and validator. If you want, you can actually maybe first of all, you can like run pmpmi. Nice. Yeah, we're actually using npm instead of kind of like Foundry dependencies because it's kind of a headache to deal with.
Yeah.
But yeah, in the meantime, I think we can go back and cool. So if you want, you can go ahead and delete the other two templates except for the hook one. Yep.
Cool. So get rid of these.
Yep. And then in test as well. Or I guess we can do that later as well.
Cool.
Great. So yeah, maybe it makes sense to kind of like check out the code of the template first before you kind of like start modifying it.
Mm-hmm.
But basically, there's a few kind of functions that are kind of in the interface for a module. So kind of like every module has to have those. So two of those are the uninstall and uninstall. And basically what they do is kind of when you add or install a module on an account, the account will call this function, and kind of then this function can set up some state. Like in our case, it'll set up kind of like your spending limits, and kind of like uninstall, I guess, like does the opposite, like it clears the state when the module is uninstalled in the account. And then if you go further down, yeah, so there's two kind of hooks. Kind of the interface for hooks has two functions. So that's pre-check and post-check. So yeah, it's kind of like the name suggests, like pre-check is called before an execution or before a batch of executions, and then post-check is called afterwards. And then at the very bottom, there's just like some metadata functions, which we don't really need to concern ourselves with too much. Just name, version, and kind of like module type.
Cool.
But yeah, so the ModuleKit, which we're kind of like using here under the hood, it also has for hooks specifically, it has another kind of base component. So this is kind of like the, I guess, like more generic base component. But I think instead what would make more sense in our case is if we import the ERC7579 hook destruct. So if you just kind of go back to the, yeah, so instead of the hook base, you can just replace base with destruct.
So it'll be
destruct. Yeah. Hook destruct, sorry. Hook. So DS, yeah, exactly. And then same in the path as well. You can just copy that into the path. Yep. I think that should be working. Do you want to open that file maybe so we can check it out as well? Does that work on VS Code? Like sometimes
Oh, like opening this up?
Nice. Yeah, exactly. So kind of like as a quick explanation, like I said, like there's kind of two functions, like pre-check and post-check. I guess like more importantly, pre-check. And basically that takes in kind of like the entire call data that's sent to the account. So in that will be the call data for like the execution. But what this hook destruct does, kind of if you scroll a bit further down, actually like further kind of like a bit more, yeah, to here, it basically like it will decode kind of this call data, and then it has different internal functions depending on kind of like what you're trying to do on the account. Does that kind of make sense? So like, for example, if you're trying to execute something on the account, it will call on execute. If it's a batch, then it will call execute batch, and it's kind of like just decodes everything for you. there's like 4 of those, and because there's execute and execute from executor, then there's also like install module, and kind of like a bunch of other functions that you could call on the account, basically.
Gotcha.
So what the destruct does is kind of like it does all the kind of like nasty destructuring for us, and we can just kind of like override.
Nice.
One thing, so right now, actually, we're shipping a new version of the ModuleKit pretty soon, in which it's optional to override these functions. But I think right now, if you could just copy all of these functions, so that we can like override them in the hook template, starting from here, from on execute.
It's great from on execute. Configs as well, or just all these?
Yeah. So right now, like we need the configs as well. Actually,
Okay.
I think to the very bottom, including the on post check as well.
Okay.
And then we need to merge the latest changes. And then we can paste that into the hook template. And like you can delete the code under module logic, so the pre-check and the post-check, because that's now taken care of by the destruct.
Okay.
And kind of instead paste those in there. Nice. Cool. And then I guess like I guess we can get started with some of the logic. So kind of the way I thought about this is kind of we need some sort of like mapping that points from like account to essentially the spending limit, right?
Mm-hmm.
So it would make sense. Maybe first of all we create like a struct for like the spending limit.
Okay.
Nice. And then I think go ahead.
Yeah, no, go ahead.
And then I guess like we need like a uint limit, like the actual limit. And then like the way I've thought about it is we could have like a mapping, which is like from a uint time period to like what is spent in that time period. And kind of that way we can kind of segment the spending into like the time period.
Time period,
as in like for example, we say like we say like this the spending limit is per week. So like week 1 I've spent like 200 and so on, I guess. Does that kind of make sense?
Yeah.
I think we want to wrap that in like a mapping. So
okay. So
just mapping and then kind of brackets, like normal brackets. Yeah, exactly.
Okay.
I think it would be from uint to uint.
Yeah. And that'll be our time period.
Yeah. Or like spent or something. Yeah. Like basically like the first uint is kind of like the time period, and then the second uint is kind of what's spent during that time period.
Gotcha.
And then and then I guess the next thing is we'd need some sort of like mapping from account kind of outside of the struct. We then want to map like account, so like address. I think we'd want to map that to another mapping. And then the first parameter there would be address, which is the token. And then that points to the spending limit struct. Nice. And then, that would be like the actual like spending limits or whatever we want to call it.
So just trying to figure out in my head what we call this. Yeah.
I guess we could call it like, what were you going to say?
So this is the address of the user being mapped to this spending limits struct.
Exactly. Okay. Yeah. Like the address of the user mapped to a token, mapped to a spending limit.
Okay. Got it.
So the idea is like you have different like limits based on like different like tokens.
Gotcha. Cool. So token limitation or token limits, I guess.
Works. Nice. Cool. yeah, I think that's kind of like the main data that we need.
Okay.
And then I guess maybe what could make sense, or maybe first of all, while you're up there, I think you actually need from the hook destruct, you need one more import, which is called execution. It's like this, like a struct. So you can just do like comma execution with a capital E. Yep. And then I think we should also import the ERC20 interface. So we can import IERC20. Sorry, from Forge. Yeah.
Okay.
Yeah, just IERC20, and then it's from Forge. Yeah, from that / interfaces / IERC20. That's all. Oh yeah, nice. Cool. Yeah, I guess let's maybe move on to the actual like logic for checking the spending limits, and then I guess we can come back to setting them. I think the easiest thing would be to create like an internal function. Like you can do this like up here or like further down, but basically like to create an internal function which takes in like the address and the call data, and then it checks like, is this an ERC20 like token transaction? Kind of like get the limit for that token and kind of like either revert or increase the limit. That's kind of like the idea there, and then we can reuse that function kind of across the different execution flows.
Okay.
Yeah, I think it'd be internal.
Internal. Okay.
Yeah, and then for arguments, we could do like address token, and bytes call data. Yeah, I guess we could call it like call data as well. But yeah, if we want to call it call data, that has to have like a capital D.
Data. Yeah.
Or data. Yeah, data works as well. Nice. Cool. So I guess the first thing we want to check is like if the call data length is more than 4. Yeah. And then I think we could check if the selector, so if like call data and then slice from 0 to 4.
Call data.
Oh yeah, actually, sorry, we called it data. My bad.
Oh yeah.
Yep. And then like the what are they called? Like square brackets from 0 to 4 to get the selector.
I'm not sure if
just like 0:4.
Oh, okay. Yeah. Okay.
Yeah. And actually, I think we have to wrap this in bytes 4 to give it like the bytes 4 type. So just we need like brackets around this. Yep. Yeah, just normal brackets. Nice. Nice. And then we can check if that's equal to, yeah, in the if condition equal to, and then we can use the IERC20 dot transfer dot selector.
Sorry.
Transfer. Dot selector. Nice. Nice. I think there might be, actually no. Okay, I think that's fine. Yeah. So basically, first we check does the data actually have like length? Otherwise, it's kind of just like a neat transfer.
Right.
And like, I mean, if we get around to it, depending on how much time we have, we could implement this for ETH as well. But right now, let's just go for ERC20s. And then the second thing is like, is this actually an ERC20 transfer?
Okay.
And then, so I guess the next thing is, if it is, then we could load the spending limit from storage. So what we would do is you can type, I think you called it, yeah, like spending limits, storage. Yeah, if it, yeah, storage as like the next, so as the next word. Because we have to specify kind of like the data location, if that makes sense.
Okay, so spending limits dot storage. Or?
No, and then space, and then storage. Storage, and
Okay.
then we need like a variable name. Actually, I think one thing that might help is like usually the convention is to have structs be capital letters. So you could change the spending limit struct to capital S, and then I think yeah there as well, and then this one as well. Yep. And then
Sorry,
yeah, we could call it
I'm
like.
not sure what's going on outside, but there's like
Yeah, all good. And then yeah, like a variable name like spending limits with small s or something like that.
small s.
Yep. And then that's equal to the token limits, which is what we call the mapping up there.
Okay, yeah.
So, and then we need kind of like the square brackets to access the mapping. So the first one would just be like message sender, which is the account. And then the second one, kind of after this bracket, we need another bracket, which should be the token.
Token, the token address.
Yeah, I think you just called it token.
Okay, I called it address. Yeah.
Yeah. No, I think token.
A token.
Yeah.
Okay. Yeah. Okay.
Nice. So yeah, does that kind of make sense? So here we basically.
Okay, got it. Yeah.
Yeah.
So
we're
taking essentially this inputted token, making sure first of all that it's an IRC20 transfer, setting it to the spending limits struct map from like the message sender to the token.
Exactly. Yeah. Yeah. So there we get the spending limit struct, and basically what the storage keyword does is kind of it tells like Solidity where that's located. So you could also do like spending limits memory, but then it would load everything into memory. So in this case, it's just kind of like a pointer to storage.
Got it.
And then I guess the next thing we could do is we could calculate the UN time period. So if we do like UN 256 time period equals. And that equals, so I guess like the way I was thinking about it, and like obviously we can do whatever we want. Like I was thinking like we could do it in terms of weeks.
Okay.
I guess we could also do it in terms of days or like months. Probably months could make sense as well. Like up to you really.
Yeah. I think weeks is fine. Yeah.
Cool. But basically we can do block.timestamp and then divide that by you can just say 1 weeks. So literally just like the number 1 and then space weeks. Yep. So that's the time period. And that essentially just like divides the timestamp by the weeks into time periods. So then yeah, I guess like the next thing is we could check like if the spending limits, which is kind of like the storage struct there, like if it actually has a limit set. Because if it doesn't have a limit set, then we can just kind of like go on, right? Because the user hasn't set a limit for that token.
So if spending limits,
yep, just dot limits, I think you called it.
Yeah.
So this is the one in the struct.
If spending limits dot limit actually exists, so
yeah, we can do is not 0.
Yeah.
Nice. So yeah, in that case, the first thing we want to find out is like how much ERC20 tokens are we actually trying to transfer. So we could do this by doing like brackets, like normal brackets. And then first a comma. and then like a uint256 value or amount or something like that. Yep, and that's equal to abi.decode at decode, I think, instead of encode.
Decode.
Yeah. And then we can do call data. Sorry, it was called data, my bad. And again, like the kind of like square braces, but this time we just do colon we just do 4 colon. So we start from 4 this time instead of going from 0 to 4. Yep. And then you can, you can just leave that blank. So if you leave it blank, it'll go to the end of the data. And then outside of the curly, not the, sorry, inside the normal braces, outside of the square braces, you can do like a comma and then normal braces again. And then in that we can do address, comma, uint256. So that basically, the first parameter to ABI decode is kind of the data, and then the second one is kind of what the data types actually are. And in this case, like we don't care about the address, like we don't care who it's transferring to, we just want to get the value of the ERC20 token.
Got it.
So yeah, then I guess we're almost getting there. So I guess like the last check we want to do is the kind of what's spent in this time period plus what we're trying to spend, is that greater than the limit? In which case we want to revert. Otherwise, we just want to increase the limit. Sorry, not the limit, increase what's spent during that time period. Does that kind of make sense?
So within this time period, have we already spent our limit? If not, cool. If we have, then we want to increase it.
If we've already spent the limit, then we want to like revert. Then we want to block the transaction.
Yeah.
And then if we haven't, then we want to increase it by the amount that we're spending now.
Okay, got it.
Right, so yeah, we can do. Yeah, we can do like if what is it called? If spending limits dot time period. Time period. Yeah. And then again the square brackets, because it's a mapping. And then we put in time period, which is the time period we calculated just above. Yep. So if that, which is kind of what we spent during this time period, plus value is greater than config limits.limit. Sorry, spending limits. Keep forgetting the variable names. So if that's greater, then the limit is already reached. So in this case, we want to just revert with like some message. Nice. And then else. Yeah, and then if that's the case, then we want to increase spending limits that time period for this time period with the value. Yep, dot time periods of time period. Yeah, then we can just do plus equals value. Nice. I think that's the logic for checking the spending limit.
Okay.
Should we kind of like walk through it again, or do you want me to walk through it again, or do you want to?
Yeah, that would be good to walk through it once more.
Cool. Do you want me to, or do you want to kind of give your interpretation?
I'll give my interpretation, I guess. Yeah. To check spending limits takes a token address and some data. We're checking if the data is actually like an ERC20 transfer. If it is, cool, we'll create our spending limits struct using message.sender as well as the token, which is the token address. We'll set our time period here. So block that's this, and then we're checking if the limit is greater than 0. So the limit has already been set. If it has been set, then we're grabbing the value of the transfer and adding it to the spending limit. Otherwise, if it's, oh no, I think I said that incorrectly. So here it's spending limits that time period. So we're checking if within the time period this value is greater than the limit that has already been set. If it has, then we revert. Otherwise, we take the value and just increment the time period.
Yep, exactly. Yeah, I think that's pretty much it we need for checking the spending limit. Nice. Cool. So I guess should we move on to actually implementing this in the functions below?
Yeah.
Cool. So let's go to the module logic functions that you copied earlier.
Down here. Okay.
Yeah, exactly. So I think first of all, you need to add like override on the virtual to all of them, where we can do it kind of one by one.
Cool.
Yeah, just here. Yeah. And then, yeah, instead of the semicolon, we just need like the curly braces to actually implement the function instead of the semicolon after returns. Yeah, exactly. And then in that case, I think you don't need that. Yeah. And then, yeah, in here, I think basically what we just do is we just call the function you created, the, I forgot the name again, check spending
limits. Yeah.
Yep. Nice. And then so basically here, kind of, like I said, like the hook destruct will route, will like decode the call data and route to here. So the address target here is in our case is the token contract. So you can just pass like target as the first argument. And then the second.
Yeah. Okay. I'm just checking. That's
yeah. And then the second argument is just call data. Yep.
Okay.
And yeah, I think that's essentially it for this function.
Cool. So on execute, whenever it's going to execute something on the account, it'll check for the spending limits.
Exactly.
Okay.
Exactly.
Cool.
And then, yeah, I guess like now we just want to basically implement the same thing in the other functions. So the difference between on execute and on execute batch is kind of, as you can tell, it's a batch.
Mm-hmm.
So yeah, I think here basically the main difference is we want to loop over. I think actually in line 78 the variable name is missing. So yeah, you can call that like executions or something. Nice. So yeah, the difference there is we just want to loop over all the executions and then call the check spending limits function for everything in the executions. Nice. So yeah, you can just do the check spending limits.
It'll be I.target. Right.
Yeah, it'll be executions and then square brackets of I to get that specific execution.
Right.
And then it'll be dot target and dot call data for the second one.
Okay.
Nice. Great. And then pretty much the same again from here. So actually, I mean, I haven't explained this before, but kind of the main difference is you have like two kind of execution flows on 7579 accounts. It's kind of one is like user triggered, which is what you call execute. It's kind of like user wants to execute something. The other one is called execute from executor. Mm-hmm. So you have this like module that calls into the account. And like for people familiar with like save, save has an execute from module function. This is essentially the same thing.
Got it.
Nice. I also think like here the variable name is missing.
Okay.
For the executions, yeah. Yeah, and override, I think you need to do as well. Nice.
Yeah. Cool.
Cool. And then the remaining functions below, like I said, right now we just need to override them. So if you just put like override on all of them, and then put like empty curly braces instead of the semicolon. Yeah, exactly. Yeah, like I said, like in the next version of the ModuleKit, you can just ignore the functions you don't want to use, and then same here for the on-post check. Nice, cool.
Metadata is good.
Yeah, I mean, if you want, you can change the name to spending limit hook, but it's not going to make a huge difference.
Yeah.
Cool. And then I guess one more thing before we maybe want to kind of like test it and see if it works is if we go to the top of the file, there's the uninstall function a bit further down. Yep, just there. So in that function, we want to set the spending limit. So what we can do is basically kind of for interface reasons, it just takes in a data argument, but we can kind of in that data, like we could decode that into like an address and a config, for example. Or sorry, an address and a limit, for example. So we could do like brackets, address token, and then comma, uint 256 limit. And that's equal to ABI.decode
the
data. Yeah, and then comma. After the data, you need like a comma, and then brackets again to give the types. So it'll just be address comma uint 256. Nice. Yeah, and then we just want to set the mapping. I think you called it. Actually, I forgot again. Yeah, token limits.
Token limits, yeah.
So we can do.
Token limits.
So the first one, the first one is message sender. Actually, one thing, so like a minor thing, but in the mapping, you can actually after address, you can put in a variable name as well. So you could do like account and then token just to make it easier to
remember.
Yeah, exactly. And then for the second address, you can put like token.
Okay.
Yeah, that way we won't get confused.
Okay. Cool. So we want token limits, message sender, and token.
Nice. And then what you can do, I mean, either you can create a struct and set that equal to the struct, or you can also just do dot limit of this, and then that equals to limits. Yeah, I think you called it limits. Nice, cool. So yeah, basically what that does is kind of when the account installs the module, you'll pass in a token and a limit, and then it sets the limit for that token. And kind of like, if we wanted to make this, I guess like maybe better to use, like we could pass like an array or something like that. But I think for now, we can just do one token.
Yeah.
Cool. I guess maybe should we look at the tests and figure out if it works?
Yeah, let's do it.
Cool. Great. I don't think you renamed the contract, right? So I think the contract should still be nice.
Yeah, still
okay.
But yeah.
Cool. So yeah, this is maybe just to explain quickly kind of what this is doing. Right now, this is obviously for the template. So you have the setup function, which is kind of like the classic Foundry test setup. Basically, first we create the hook, and then we label it. So it'll just kind of be nice when we kind of like display the call traces. And then kind of on line 30, we create the account instance. So basically, this is potentially, like in my opinion, like the biggest value out of the ModuleKit is actually kind of like when it comes to testing. Because if we actually wanted to use kind of the module in production now, like there'd be kind of the entire 437 flow, right? So there's like the bundlers, then like the entry point, the account, and kind of the entry point calls the account first during validation, then during execution, and kind of like encoding the call data in the right way. But basically what the module does is it kind of like abstracts all of that away. So first you just create the account instance. So just like here, kind of instance is equal make account instance. And then kind of in line 44, you can just do instance.exec. So then basically under the hood, that creates like a 437 transaction. Like I said, like sends it to the entry point calls the account. But yeah, here everything is kind of abstracted away. So it's actually super, super nice.
Nice.
Does that kind of like all make sense?
Yeah, makes sense.
Cool. So yeah, I guess the first thing we want to do is in line 31, or kind of like after line 31, we need to, so yeah, maybe to explain kind of line 33, we call instance.install module, we give it the hook and kind of like the address. But now we also need to pass the right data. So in this case, the data will be the token address and the kind of like the limit amount. Which actually brings me to maybe first of all, we want to use a mock ERC20 token to actually like, so we can import mock ERC20, which is from Soulmate. Yep, the third one /test /utils /mocks and then /mock ERC20. That's all.
Okay.
It's a long one. Yeah, that's all. I think capital M for the mock ERC20. Yep. And then we can set that up in line like 22 or something. We just do kind of mock ERC20 internal token or something like that. Yep. And then yeah, in here we set token equal to new mock ERC20 just somewhere in the setup function. So we actually deploy the contract.
Okay, so new mock ERC20.
Yep. So token is equal to new mock ERC20 with like brackets. So the token is first. It's like the other way around, yeah.
Yeah. Token equals new mock ERC20.
And then bracket, yeah. And then yeah, actually that takes in a couple of arguments. So you need like a name. We could just do like USDC or something. And then symbol, we could just do the same, USDC as well. And then like the final one is decimals, so you could just do like 6 or 18 or anything. USDC has 6 decimals, so oh yeah, 18
6.
Cool. So yeah, I guess going back to line 34, we could we could do it inline as well, but yeah, we could do like bytes memory, like setup data. Equals to ABI encode. Yep. And then first we want address of token. So address brackets token. Yeah, because the token right now is of type mock ERC20, so we want the address, and then I guess some spending limits. We could just do like 1 ether. Isn't like this won't actually use ether. It'll just kind of ether. I think it is basically just like a big number. And then we can pass this setup data in the following line instead of kind of at the end there for data instead of the quotes. We can just pass setup data. Cool. Great. I guess should we maybe see if it runs first of all, and then kind of write the actual test.
So this is forge test.
Yep. Okay, some dependency issue. Could you maybe try npm. You already downloaded the dependencies, right?
Yeah, I already did npmi.
Hmm.
Do it again just in case, but
Okay. It's a result file. Let's see.
so lady.
Okay. Yeah, I think it's some like Foundry remapping issue essentially.
Okay.
But okay, let me have a think about how we can solve this. But yeah, maybe in the meantime, let's write the test.
Okay, so set up and then execute the test.
Yep.
So we're gonna
Yeah.
do
So right.
similar.
Yeah.
For this, yeah.
Yeah. We don't actually need the setup data, but I think so. Right now, what the test does is it just transfers 1 ETH to the target.
Okay.
So I guess instead we want to transfer, like do an ERC20 transfer for the token. So I guess like in line 48, instead of passing target, we could pass address token. Yep. And then value would just be 0. And then for call data, we could do ABI dot encode call. Yeah, encode call.
Oh.
Yep. And then we'd do like IERC20 20.transfer. Yeah, capital E. Yep. Or capital everything, yeah. And then comma, and then we need brackets again. And then, yeah, so first of all, there's a target, so we could just do target. And then second one is value, so we can just do value as well. Great. And then I guess here in line 45, it checks the ETH balance. But what we could do instead is we could do token.balance of target, if that makes sense. So instead of target.balance, we could do token.balance of.
Yeah. Of the target.
Yeah, target, yeah. And then kind of we could use the same code in line 51. Instead of target.balance, we could do token.target.balance. So basically what that does is we just get the previous balance and then get the balance afterwards to actually make sure that the transfer happened. Cool. Okay. Nice. Yeah, I guess like there's the annoying remapping issue now.
Yeah.
Yeah, I guess we can try to debug it. So I guess what's happening here is, okay, could you maybe go to the remappings in this folder? And then on line 12, I'm not sure if this will work, could you just add source? So src/. Yeah, try that. But I think it might break something. Okay. Okay. Interesting. What is this? Okay. Yeah, okay. I guess we can remove that again. Interesting. I was running it before and it worked all right. Could you maybe
it's very rare that like during a live coding it'll work as it worked like an hour ago.
Yeah. Oh, actually, I think I know what the issue is. Do you by any chance have PNPM or no?
No.
Okay. Because I think what the issue is basically there's a PNPM lock. And there it has like the locks of kind of like which version to use. But then npm created a new lock, so it uses kind of like newer versions of those.
Let me grab that real quick. I may have it. Let me see. I do. Okay.
Nice. Okay. So, yeah. So maybe first of all, if you delete the node modules and the package lock.json.
And we want to remove package.json, right?
No, it's not. Oh,
Okay.
wait.
I spelled it wrong, so nothing should have happened.
No, we want to remove the package lock.json,
Okay.
the green one that was created by lock.json. Yeah.
Okay.
Nice. Okay. And now if you run pnpm or install. Okay. A lot of stuff is being installed.
This is taking longer than the npmi, so I guess
Yeah.
it's working.
Yeah, I think so. Kind of funny because of. Okay, nice. So maybe let's run forge test and hope it works. Okay, same error. Okay, that's not great. Maybe could you try like deleting the node modules again and just trying again? But I guess that probably won't make a difference. Okay. Yeah. Okay. Maybe let's try running forge test again. Okay. Yeah, doesn't make a difference. How about I guess like, I mean, one thing we could do, so I do have a repo where I was kind of like building this first.
Okay.
So maybe we could switch to that repo, like it was working there.
Yeah.
Just kind of for the continuity of the demo. If you go to GitHub, if you go to, it's, if you go to / copycat, yes, instead of Rhinestone, as like the username.
Okay.
Or I guess so copy -cat, and then instead of module template, it's called spending -limit -hook. Nice. Okay. So maybe let's clone that one and see if it works there. Nice.
Do pnpm install.
Okay. This will be interesting. Moment of truth.
Okay.
Yeah, let's do forge test and hope for the best. That's interesting. That's very interesting. Okay. Would it make sense for me to share my screen instead?
Yeah, I think that'd be good.
Cool. So let me share my screen. Great. Can you see this? Ooh.
Just added. Okay.
Nice. Do you want me to zoom in a little bit?
Yeah, I think zoom.
Like this. Is that good?
That.
Nice. Okay, great. Let me just run forge test. Okay, still working for me. That's good. So yeah, maybe, so this is in my repo, but basically kind of very similar to what we were building. We kind of have this mapping to spending limits. Kind of actually for me, I take in an array of configs instead of just taking one, which we were doing. But yeah, maybe kind of getting to the test. Let's make this bigger. So yeah, kind of similar to what you had, kind of set up the hook, set up the mock ERC20. Then I guess here it's a bit more complicated because we have an array, but basically the same thing. We pass in the token and then pass in the limit. And then we pass that as the install data. So that looks pretty much the same as what you had, right?
Right.
Nice. And then, sorry, and then have the exec function, which basically, once again, pretty much actually exactly the same as what you have. So then maybe let's run the tests first.
Can we get this zoomed in?
Oh, yes. Is that good?
Maybe a couple more.
Couple more.
Okay.
This one.
Yeah.
Yeah. Okay. Nice. So yeah, maybe it makes sense to just quickly, or I guess like, yeah, you tell me what do you think would make the most sense. But one thing I was thinking about is just kind of like running through the call trace to kind of show what's happening under the hood.
Yeah.
In this test. So yeah, maybe just for comparison again, basically this is the test. And essentially what we do is we like transfer this token, this value to this target, and then like check before what the balance is and check that the balance is kind of increased afterwards. And basically because we installed the hook kind of first, that hook should be called in between and it should kind of enforce the spending limits. So kind of, as you can see here, there's a bunch of like stuff happening, which is kind of like the 437, kind of like integration, I guess. So the entry point is called, which then calls the account, which does validation. We don't really care about that. Then kind of is the entry point again, and then kind of this is the execution phase. So I guess just like as a quick recap for anyone like not familiar with 437, is basically how it works is you have this contract which is called the entry point, and this contract is called, and basically what it does, it will first call validate on the account. So in this case, actually, maybe unhelpfully, we've called the account spending limit hook. So when you see spending limit hook here, it's actually the account that's being called. So maybe we should change that. So we'll call validation first, and it'll do the entire validation phase. And then if the account says, "Yep, this is like valid, let's execute," then the entry point will call execute. So basically, account is called. It's a proxy, so it'll call kind of to the proxy implementation, and then this will call our. Yeah, this is very confusing now. This is the actual hook, and that's called. We call pre-check on the actual hook, and then kind of in here, basically what happens is we check the spending limit and make sure kind of pretty much like the logic that we wrote here. I think I have it up here. We kind of execute all of this logic. Does that kind of make sense so far?
Yeah, makes sense.
Cool. And then let's check out a second case where we, yeah. So this is a case. Let me show you the test case. Yeah, so here are the test case. So first of all, we just do the same thing. We just call this function. And then afterwards, we call it again. The problem is we set the spending limit to 1 ether. Then we transfer 1 ether, as in like 1 ether in token.
Right.
And then we try to do it again. And obviously this shouldn't work. So let's see. So once again, validation phase, we don't care. Execution phase, hook says it's fine. We do the transfer. Then kind of second user op starts here, validation phase. We don't care. Execute, hook is called, and actually hook says spending limit exceeded. So in this case, yeah, like we're over the 1 ether in this token spending limit, so the hook will just revert. So this transaction won't, or this user operation won't go through. Yeah, that's essentially. So I guess like here we can see that both like during the first user operation, we actually increased kind of the token that we spent, because otherwise it wouldn't be more in kind of the second user operation. And then we can also see that in the second user operation, it actually figures out that it's more than our spending limit and then reverts. So yeah, I guess that's kind of like showing how it works.
Nice. So essentially, once the user op gets to the execution phase, that's when the hook on the account is actually called, right?
Exactly.
Okay.
Yep. So you can see, let me show it again. Yeah, so execute, this is the execute function, and kind of the very first thing in that function basically is to call the hook with pre-check. And then kind of after this is done, then the actual like execution happens, in this case, the transfer. And then the hook is called again with post check. Like in this case, we don't use post check, so we don't really care. But yeah, so you can see kind of like before, after, and kind of like the execution happens in between.
Got it. Makes sense. Yeah. No, that was pretty easy to follow.
Cool. That's great. Yeah. I guess like one thing is, so in Foundry, you have vm.expect revert. So you can do this, and like you can ignore this. This is basically just like to whether we should check the equality, because obviously if this reverts, then this will throw an error. So we can just ignore this. But so I guess like we would expect, so the first kind of execution passes, and then the second one we expect to revert, right? Because the spending limit hook reverts. Let's try and see what happens. Compiling. Yeah, so it actually says the call did not revert as expected, which is strange, because as we saw before, the call should actually revert. I don't know where it is here now, but is this the right thing? But as you saw before, basically the hook will say like the spending limit is reached, so it should revert. The problem is that in 437, when something reverts during the execution phase, the whole transaction doesn't actually revert. So vm.expect revert doesn't actually work in this case. Instead, the ModuleKit has expect 437 revert.
Interesting.
So what actually happens is if a user operation reverts in execution, then the transaction passes, but an event is emitted, right. And that event says it reverted. So basically, this is kind of similar to VM expect revert, but it actually parses the event and kind of like does all the kind of like lifting for you. In that case,
there's something for that specific revert event.
Exactly. Yeah, or just in general, kind of like when using like these user ops, and now we can see, okay, like the transaction actually reverted, and we call this revert.
Got it.
And then I wrote just quickly, like I wrote 2 more test cases. So this is for multiple periods. So obviously, kind of like we said, we chose a week, but kind of arbitrary. We have these like periods, and kind of like after each period, the spending limit should like reset, right? So the idea is first we execute. So this basically just sets the timestamp to 0. Then we execute, and then we execute again. And kind of in this case, we saw that if we execute and execute again, the spending limit is reached, so it should revert. But if in between we kind of increment the timestamp by a week, we can actually see that it won't revert, because kind of this will then be in our new kind of like time period, basically. So we can see that the spending limit hook kind of separates your spending into the different time periods. Does that kind of make sense?
Makes sense. Cool.
No, this is basically just testing that it works.
No, I actually have never seen a kind of like a way to test the 437 like user ops before. So this is really cool. Definitely learned something new there.
Nice. Yeah, that's great. Yeah, I mean, we got started kind of like working in Foundry, like a lot of kind of people before, and still do kind of like people use Hardhat because it's just much easier to hook it up with the 437 infrastructure. But kind of we were building stuff in Foundry, and then realized like a lot of this stuff is just like kind of very annoying or very hard to actually kind of do right now. So yeah, this is kind of, I think I said it before, but why to me like the biggest value out of the ModuleKit is actually the kind of like this whole testing framework, because it does all of this stuff for you. And actually, like one final thing is the ModuleKit can also calculate the gas used. So once again, like Foundry can definitely like, it can tell you how much gas you use for certain function calls and so on. But a user op is like not really a function call. right? Like it's kind of like it has these different phases, and kind of like there's some overhead that isn't actually, you don't actually pay for on chain, and so on. So what we can do is we can call this, and this basically just like sets a name for kind of where we want to print this out. And then we can do, we can call gas equals true forge test. So this just kind of sets like an environment variable essentially. And if we run this, basically the effect is that in this gas calculations folder, we get a JSON, which tells us kind of like like what is the total gas, and then also kind of separated into the 437 phases. So I guess I talked about the validation and the execution phase, but technically there's also the creation phase. So if your account hasn't been created, it'll be created. And then there's also, this is kind of still experimental, but it also calculates the call data cost on different rollups. Because on rollups, I guess this is especially like pre 4844, but I guess still matters to some extent. Is like most of the cost, or like a lot of the cost you pay for, is call data to L1, I guess nav to blobs. So yeah, that's another kind of like neat thing that you have there. Whereas like if you just did like for snapshot or something like that, it would just kind of give you the overall gas, but it'd be much harder to kind of like measure. And as you can see here, if we actually change something, it would show us the diff as well. So that's quite cool.
Nice. That's awesome, man. Thank you. Thank you for going through all this. It was really, it's really cool to just like see like what things are you're capable of doing with like smart contract wallets. I remember like when I was first like learning about kind of abstraction, like the whole like arbitrary validation or execution logic thing was just like, okay, what does this even mean? And now you finally see what all of this stuff means when you like bring in like the modules and like you're adding all this like additional functionality on top of your account. So this was really, really cool to see.
Exactly. Yeah. I mean, first of all, like, yeah, it was definitely great and super fun to walk through with it with you. But yeah, like you said, like also super excited about kind of the expressibility of all the stuff you can do with smart accounts and kind of like with these modules.
Definitely, man. Cool. Is there anything else that you would want to leave for folks watching? Anything else for them to check out or look out for?
Yeah, I think like I think you showed it earlier, kind of like our docs is kind of like the best place to get started. I guess like one kind of piece of content, yeah, you can kind of see it below now. I guess like one, not piece of content, but kind of one note is kind of like at Rhinestone, like I said, we're building infrastructure for these modular accounts. And that means on the one hand, kind of like we showed today, like we have tooling and kind of like other infrastructure on chain and stuff like that for actually building modules, for distributing modules, for using modules. But on the other hand, we're also kind of working on more client side, so application kind of like tooling to actually use those modules as well. Because one of the kind of very exciting things that we think about, or that we are like, is part of our thesis, I guess, about this modular smart account ecosystem, is that people that build modules don't necessarily need to be the same people that kind of use those modules in applications. Kind of like we talked about earlier, whether that's a dApp or a wallet. So it's quite cool that you can have this separation there, where some people like build modules like the on-chain contracts, and other people just use them like in the front end. So if you go to our docs, you'll see like the module SDK, which is different from the ModuleKit. So the ModuleKit is kind of like building modules, and the module SDK is kind of like consuming them like in the front end. So I think that's another, I guess, point to note.
Nice. Awesome. Cool. Thank you again for, hopping on. If y'all want to follow along with the Rhinestone journey, definitely give Konrad a follow at Abstractor, as well as Rhinestone at Rhinestone WTF. Thank you again for being on this episode. Next week's episode will be announced either over the weekend or on Monday. But thank you all again for tuning in. And thank you, Konrad, for being part of this episode.
Yeah, thank you so much. Thank you for having me. It was really fun.
Cool. Same here.
Great.